Hello everyone. I would like to continue with the previous video. We were working with finding the volume of a solid, and let me backtrack a bit. Alright, so let me backtrack and show everyone that we are going to find the volume of a solid generated by the area bounded by the following curves. So, and we are going to use this method. So when we use this method, we are going to take a look at the axis of rotation. So if the axis of rotation is the y-axis, and you draw the y-axis, and this method is all about perpendicular. Okay, so perpendicular, just remember that very important fact about this method. So what is perpendicular? Perpendicular means that you are going to draw the element. So why do we use element? Because the element has a lot to do with finding the area between the two curves. So you will draw the element that perpendicular to the axis of rotation. And the axis of rotation is given to us in this case is the y-axis. So perpendicular to the y-axis will be the horizontal element. So the horizontal element is the dy. So knowing that it's a dy, you are choosing these formulas right here. Okay, so the formulas say volume equal to pi times integral from c to d of x squared dy. Why do we have put x squared? Because if the formula said that x squared means that this x is a function in term of y. So it means that you have to isolate the given equation so that it will be equal to x. Okay, so isolate the x means you solve for x. If you solve for x, then you have a function in term of y, and you square that, and then apply to these formulas, you are going to figure out the volume. And what is C and D? C and D are the upper and the lower limit associated with your dy. So that means it's your y value. So in this case, what we have, we are given this parabola open to the side. We have y equal to 4, we have y equal to 2, x equal to 0. Rotated by the y-axis, we identify the areas, and then we follow the rule y-axis. We have the horizontal element, and this shape right here, you're going to rotate it about the y-axis. And when you rotate about the y-axis, you are going to generate this shape. So here's what I have as I take an image for everyone. This is the shape that I have, and it's more like half of it to show the cross-section area. And then what I have next is I am showing you the solid right here, cut in half, and it's actually generated solid about the y-axis in this case. Okay, and we are about to find the volume of this solid given all the information. And I emphasize to everyone about these formulas, and we need to find out what x is so that we can square the x. And the function given to us in this case is y equal to x minus 3. And if we square both sides of this equation, we can isolate the x. Okay, so y squared equal to square root x minus 3, all of it square. If you square something of the square root, then this cancel out, so you just have x minus 3 left. Then you bring minus 3 over to this side of the equation because you want to solve for x. So in this case, you have y squared plus 3 equal to x. Then because of the x squared, therefore you are going to square both sides, right? So you square the x, that means you have to square this function as well. And I kind of went over how we have a function and we square that, and if it's a square root, and then we square all of it, and we end up with just the radicand here. So to explain this to everyone, I use the concept of exponent. So if you have x minus 3 as a square root, then you can convert that into the exponent a half. Okay, so we've learned about radical versus exponent in at the beginning of the term. So everyone realized right away that the square root of any function, you can take the square root away, but you raise that to exponent a half. And then you want to square this. And when you have a function or a base raised to the exponent m, and then this whole thing is called the power, and then you raise this power to another exponent, it means that you have to take two exponent and you multiply with each other. So in this case, you take a half times 2, a half times 2, which is 1. Therefore, you have x minus 3 in the bracket raised to exponent 1. And raised to exponent 1, I don't have to write that. Therefore, I just have x minus 3. Okay, so you know that this x squared, you need to substitute into here, right? You need to substitute in, and then you need to have pi multiplied by the integral of, in this case, the dy, that means given to us as 2 and 4. So 2 and 4, okay? And in this case, I have y squared plus 3, all of it, square dy. So before we integrate, we are checking to see if we have the correct integral to work with. Here's my dy, and my function is in terms of y. But how do we integrate this? It's best that we expand this, and then we integrate each term individually. Okay, so let's pause over here and go back to this line, and we are going to square both sides. Okay, so squaring this, I must perform this step. I am going to do this. Y squared plus 3, all of it square. That means I write it twice. Okay, I hope everyone agree at this point. The exponent 2 tells me that I have to multiply the base by itself twice. So I have y squared plus 3 multiply y squared plus 3. So this one I'm going to expand. So I take this times that. Okay, so I will have is as y to the exponent 4 plus 3y squared plus 3y squared plus 9 equal to x squared. Okay, so combine these two terms, I should have y to the exponent 4 plus 6 y squared plus 9 equal to x squared. Alright, okay, so this right here, what I am going to do is I will ask everyone to review that. Okay, and I am going to write y4 plus 6y squared plus 9 into my integrand over here. So pi from 2 to 4. So this integral is y4 plus 6y squared plus 9, all of it in the bracket dy. Okay, so now I'm to integrate each term individually. Alright, okay. Integrate each term individually. I should end up with pi. No more integral sign because I am going to integrate. Okay, I did that on purpose just to make sure to remind everyone that as soon as you integrate, you are going to take away your integral sign. If you apply fundamental theorem, it means that you are whatever you have in here. Okay, whatever you have in here, as a result, you are going to write it as evaluate this from 2 to 4. Okay, so keep that in mind. Alright, okay, so let's do this step by step using this bracket just to make sure. So I have y to the exponent 4. The integral for that is 1 over 5 y to the exponent 5. Okay, so add 1 divided by the result. And the next one should be 6 divided by 3 y to the exponent 3. Okay, so add 1 to the 2 divided by the result. Okay, what is the integral of 9? Integral of 9 is 9y. Because over here, it should be y to the exponent 0, right? Okay, y to the exponent 0 is 1, so 9 times 1 is just 9, because you integrate it in terms of y, so you have to create this. Y to the 0, 0 plus 1 is 1, so 9 divided by 1 is just 9, and y, this is y, actually y to the exponent 1. This is not done yet. I need to draw this line, and then I am going to tell everyone that I'm going to apply fundamental theorem next by evaluating this result from the 4, subtract the value of the 2. Okay, so I am going to apply fundamental theorem on this page. Let's see if I give myself some space. I did not. So let me allow me some time so I can copy this here. Note. Okay. So I just want to rewrite what I have done on this side onto this page for everyone. Y squared equal to the square root of x minus 3, all of it square. So that means that I have y squared equal to x minus 3. So y is that. Okay, so the y here is, I am explaining to everyone that x minus 3 to the exponent a half, and all of it to the exponent 2. So x minus 3 could be a half times 2. So therefore I have x minus 3 to the exponent 1, which is x minus 3. So I just want to rewrite what I have done on this page. So when I erase it, it's still here. Okay. Okay, so let me erase this so I can use this page to apply fundamental theorem to the integrand that I just complete to find the value for this solid. Okay. Thank you everyone for your patience. So let's rewrite this again. I rewrite this as volume equal to pi times 1 over 5, okay, of y to the exponent 5. So 1 over 5 of y to the exponent 5. Okay, here you see 6 divided by 3. I will write it as 2. 2 times y to the exponent 3 plus 9 times y, evaluate from 2 to 4. It means that it will be written like this: pi times the f of 4 subtract the capital F of 1. Okay, so this is the fundamental theorem that I'm talking about. You find the result of your integral, and then you have to evaluate your variable from the upper limit, subtract the lower limit. So that is the fundamental theorem right here. So now you are going to rewrite all of this variable, replace it with 4, and then you have to subtract with all of this variable, evaluate at the value of 1. So you see, this is what I will write next. So volume is pi. Okay, so let me tell you how I did that. So I put this bracket here. So 1 over 5 of 4 to the exponent 5 plus 2 times 4 to the exponent 3 plus 9 times 4. So close this. This is my f 4. Okay, I should just write it in. So this is my F4. Okay, subtract this, exact same thing, but now I'm going to replace this by 2. 2 to the 5 plus 2 times 2 to the 3 plus 9 times 2 to just time 2. So here should be f of 2. I'm sorry. Okay, f of 2. So this is my f of 2. Okay, let me double check. So this is good. Okay, 1 over 5. Where the y is, you replace by 4. 2 times y to the exponent 3. Where the y is, you replace by 4. Where the y is, you replace by 4. So the same thing now, I'm working with f of 2. So where the y is, I will replace by 2. Where the y is, I replace by 2. So where the y is, I replace by 2. So from here, calculate this. I should have pi. And this bracket, this should give me this number divided by 5. Okay. Take 4 raised to the exponent 5. Okay, I'm reaching to my calculator just to make sure that I've done it correct. Yes, okay. So I got it right. I did it in my head, so I just have to make sure. Now this one should be 128. Okay. You can take 4 to the exponent 3 and then you multiply by 2. I should be correct here. And this is 36. Okay. So this part is just the first part of it. Now I subtract that with the second part. And then I close the bracket right here. So this should be 32 divided by 5. Should be plus the 16. Yes. And plus 18. Okay. So volume is pi, and what is this part? I do step by step. I tend to do step by step. So it's 10 to 4 plus 820 divided by 5. Okay, so this one I have 32 plus 170 divided by 5 because I take common denominator here. So 128 plus 36 is equal to 164, and I multiply by 5 so that I can get 820 divided by 5 because I want to keep the common denominator because I have to provide the exact answer for the volumes. So at this point, I don't want you to start working with your decimal, so make sure that you familiar yourself with the fraction. Now over here I have 16 plus 18. Okay, 16 plus 18 equal to 34, and I multiply that by 5, so it become 170, so I have the common denominator of 5. Okay, so now if you use your calculator, you should have alright, so this part is 1,844 divided by 5, subtract 170, so I have 202 divided by 5, and if I take this number, subtract this number, I should end up with 1642. Yeah, okay. So pi times 1642 divided by 5. So in this case, you write it as 1642 divided by 5 times pi, unit cube. Alright, so this is the answer that you should give. Don't try to take this divided by 5 multiplied by pi. This is the exact answer that requires, and also is the answer that I give throughout the entire unit in terms of calculate the volumes. And calculate volume, it should be unit cube. Okay, so I have another 10 minutes. I hope you don't mind if I kind of go backtrack a little bit to go over everything that I just did. Okay, so now I would like everyone to, before I do that, I would like everyone to see that this video transcript that I post online will have the exercise for you to work with. Okay, so you see it is symbol of the man thinking right here is where I tend to put all the exercise. Okay, so in this case, I ask you to find a volume generated by a region revolving by the x-axis. So I give everyone the hint. Okay, so first of all, what you want to do is you want to draw the arrows going through the x-axis to remind yourself that this is um, the axis that you have to base on in order to draw your elements. Okay, so the elements is the one that define what formulas that you have to use. Okay, so in this case, according to this arrow going through the x-axis, my element has to be perpendicular to the axis of rotation. So the one that perpendicular is this one. Alright, okay. So right here, I should have this perpendicular too. Then what is this element? This one is dx. So because it's dx and you are going to use this method, then what formulas are you going to use? So at the same time, I want to show everyone that this is the page that I prepare for everyone as the summary. So now you see, here's this method, and here's also this method, that you have two formulas to work with. So which one do you choose? So you need to choose the dx, because according to that exercise, you are going to draw the vertical element of dx. Okay, so let's get back to this. Okay, so then the formula you have to use is v equal to pi integral from a to b because of the dx, and then y squared times dx. Alright, okay. So I quickly give everyone a hint. Now you have to identify y equal to 0, x equal to 4, and then identify y equal to 3 times square root x, which is this parabola open to the side, this one here, and this one should be x equal to 4, and this one should be y equal to 0. Okay, I have full solution posted, but I just want to show everyone how to analyze the question. So when you have to work with questions like this, okay, first of all, take a look at what method they want you to use. They want to use this method. Then you are going to check with your formula sheet. This method is either this formulas or this formulas that you have to use. How do you know which one is the element that you are going to draw, which is perpendicular to the axis of rotation? So perpendicular to this axis of rotation is dx, so you are going to use these formulas with the dx. And the axis of rotation is given to you. Okay, I will always give you the axis of rotation. You never have to guess, okay? So in mechanical engineering or photonic engineering, when you are working with anything, you always have to decide what axis of rotation that you are going to use, okay? So this information will always be given to you. And this information also be given to you. What method to use and what is the axis of rotation. And from these two information, you can pull out the formula that you need. Alright, so let's go to the next example. Okay, so this one, I have used this method. Okay, use this method, and then is about the x-axis. Okay, so that means you are going to analyze, and you are going to use the formula that you need to identify. So here's the x-axis. So I'm going to draw it like this around the x-axis of rotation. Okay, and then I'm going to draw this element. Okay, you see that? Perpendicular to the axis of rotation. So that means it's the same formulas as I used above. Y squared times dx. I just want to make sure that this one I have the pi. Yes, I do. Okay, so you also have to use that formulas. So this element you see is very important because this one is the key. Okay, this one is the key, perpendicular to the axis of rotation. And the next one, this one to the y-axis. Okay, using the this method, y-axis, you are going to draw the y-axis and the element perpendicular to that axis of rotation. So this one is what? dy, right? Okay, so this one, because of the horizontal element, is the dy. So when it's a dy, what formulas are we going to use? We are going to use v equal to pi from c to d of y squared times dy. Okay, and let's see if I have any more question. The same here, I give you, this is the y-axis as well, and then it's the same formulas as I identify for everyone. Pi c to d, and it's x squared times dy. Okay, because of the y-axis. Okay, so rotate about the y-axis here, and we are going to draw this. Alright, so that's why it is a dy. Okay, but don't forget, before you can find the volume, you have to identify the area. Okay, before you find the volume, you have to identify the area. So I'm going to let you work with this exercise. I have 4 solution posted for everyone, but then I have time, and I will probably pick up like maybe 1 or 2. Or if you have any question, you should send me an email, and I will make a video, and I will go over this with everyone. But hopefully the solution that I posted online will clarify everything. Okay, so um, it, remember the very 2 important informations. The method they ask you to use and the axis of rotation will tell you what formula that you are going to use. Okay, so after you get the correct formulas, the rest should be easy because you already know how to isolate the variable. You already know that if you have dx, your function has to be in terms of x. Okay, because dx, the upper and the lower limit will be the x value. So if you are going to use dy, okay, then the function has to be in terms of y, and the upper and the lower limit, it has to be for the value of y. Okay, so I think I did give lots of details, okay, regarding example number 2. I repeat part of it as well because and I think we are good at this point. So don't forget to work on the exercise, and don't hesitate to send me an email if you have any question about this. I'm happy to make a video to go over any question that you have. All right. Thank you, everyone.